All right, so let's talk about some of the problems from the EVT IVT MVT packet that you requested. And again, you'll see in the note I made on Canvas, these may not be exactly the right problems because the picture I took was blurry. But if they are not the exact right problems, I will go back and make another video sort of wrapping up the problems that you would like to see. So the problems I saw, that I think I saw, were number 6, covered in the same video, and I will timestamp the beginnings of each problem in a comment on the video. All right, so number 6 first. So we have f of x is sine of x over 2, and you're asked to find c in this interval that satisfies the mean value theorem. So first thing with the mean value theorem is we would need to know that this is differentiable, and it is because sine is differentiable and x over 2 is differentiable. So I'm going to find the sine of 3 pi over 2, which would be 3 pi over 2 divided by 2, minus the sine of pi over 2, it's pi over 2 divided by 2, over 3 pi over 2 minus pi over 2. Now, sine of 3 pi over 2 and sine of 3 pi over 4 and sine of pi over 4 are both root 2 over 2, so that's going to be 0 on top, over pi, which is just 0. So now I want to find where the IROC equals that. So when you take the derivative of sine of x over 2, it's chain rule. So the derivative of sine is cosine. The x over 2 stays the same. And then x over 2 is the same thing as 1/2 x. So times 1/2. And we want that to equal 0. So then basically, cosine of x over 2 has to equal 0. And the place on the unit circle where cosine equals 0 is pi over 2 and 3 pi over 2. So that's x over 2 would have to equal pi over 2, 3 pi over 2. And I multiply both sides by 2. And remember, the mean value theorem says I want things that are in the interval. 3 pi is not, so the answer is pi. Number 10. These are all going to be... Now, question number 10. We're given a table of values of f and f prime, but we're asked several questions about this function h. And the function h is right here. H of x is f of 2x. Which of the following statements must be true? Now, the first, h is increasing from 2 to 4. Now, if we look at the actual chart, yes, the y values go up from 2 to 4, and yes, the slopes are positive at 2 and 4, but we don't know what's going on in between these x values. The graph could actually be like at 2, 4, and 4, 9, but then do something like positive slope there, and then back to a positive slope here. We just don't know. So we can't say that one is true necessarily. It could be, but it's not required to be. Now, for parts 2 and 3, since we're trying to deal with h both of these times, it's really useful to get the h stuff so we can figure out what to do. So we're trying to figure out if there exists some c where x is between 0 and 4, such that h of c is 12. So we're talking about h of c. So I have endpoints 0 and 4. So I'm going to find h of 0 and h of 4 to start. Those are my endpoint y values. And why am I looking for y values? Because the question is asking about a y value. H of c equals 12. So when I plug in 0 in for the x in h, that would give me f of 2 times 0, which is f of 0. H of 4 would give me f of 2 times 4, which is f of 8. And then I look in the chart. f of 0 is 3, and f of 8 is 13. Now, we were told the function's differentiable. And since the function's differentiable and it's continuous, you see how the y value goes from 3 to 13? Since it's continuous, that means I had to pass through every y value on the way from 3 to 13 by the intermediate value theorem. And 12 happens to be between 3 and 13. So by the intermediate value theorem, it has to pass through 12. So that one is correct. Now if we look at number 3, it's asking about h prime of c, and it's asking for the interval from 0 to 2. So I'm going to look at the h values again. H of 0, h of 2. H of 0 again would be f of 0, f of 2 times 0. h of 2 will be f of 2 times 2. And I can look at the chart. F of 0, 3. F of 4, 9. Now notice this one isn't asking about y values like part 2 did. It's asking about a rate of change, an instantaneous rate of change. So whenever you're given a function and you're asked something about its rate of change, some sort of connection there, you can sort of think about mean value theorem instead of intermediate or extreme value theorem. So mean value theorem says if I find the AROC, which would be the change in y, over the change in x. Now don't let that fool you. The change in x is not the change in the x's plugged into the f, but the original x's we plugged in to start with. That would give me 6 over 2, which is 3. And notice the problems did say that it's differentiable, right? So when this is differentiable, by the way, h, when you compose differentiable functions, it's also differentiable. The mean value theorem guarantees that at some point the AROC would equal the IROC. So this is true by the mean value theorem. So 2 and 3 are the ones that are guaranteed. All right, and number 11. So let's look at number 11 now. You're given a function that's continuous for an interval and differentiable for the same interval but not including the endpoints. And you're given y values. F of 2 is -5, f of 1 is 4, which of the following statements could be false? So let's start with intermediate value theorem. Now, again, we're given y values. And on 2 of the questions, actually 3 of the questions, we're asked about y values. Part A, part C, and part E. Now we're told continuous and differentiable. So if I look at the y values go from -5 to 4. So every number between those should be hit because of the intermediate value theorem. So if I look at choice A, 0, in between -5 and 4. So that has to be true. And that's by the by the intermediate value theorem, what I just said. If you look at choice C, f of c is 3, that is also between -5 and 4. So that has to be true, also by the intermediate value theorem. If you look at choice E, if you read this, there exists some c such that f of c, which is the y value, is bigger than any other y value in the interval. That's the extreme value theorem. It says there's a highest y value. And since this is continuous, that is also true. So it's none of the ones that relate just to the function, because all of those are guaranteed to be true. So let's look at the ones that are related to the derivative. Again, what we have here are 2 y values, and we're asked about slopes. So whenever you have a function and you're asked about something that's one level below it, the derivative, think of the mean value theorem. So again, mean value theorem, I have to find the AROC. So change in y over change in x. So the AROC is 3, and since the function was differentiable, there's guaranteed that there's some point in the middle such that f prime of a number equals that AROC. So if you look at your choices, that means D has to be true. So the only one that can be false is B. There's nothing that guarantees with the information that you're given that the slope at a particular point has to be 0. All right, and number 14. Now, when you're reading number 14, it's important to understand what information you're given, right? So you're given velocity and time. So this is a function of velocity. So anytime you're asked about velocity in this problem, you're going to think of it as being on the same level as the function. Kind of like we were saying, hey, you're given a y value, think about it as being intermediate value theorem or extreme value theorem. If you're given a derivative of that, think of it as the mean value theorem. Anytime we're talking about velocity, then this would be thinking about one of the IVT or the EVT. If we were asked about the derivative of velocity, which is acceleration, we would be thinking of mean value theorem. So the question, part B, says, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time between 5 and 8? So if I focus on that time interval between 5 and 8, and again, I'm talking about velocity, so the functions level that I'm on, they told you that the function is differentiable, so it has to be continuous. And that means as it goes from negative 40 to from 40 to negative 120, it has to pass through every number on the way by the extreme value theorem. So yeah, since the velocity is differentiable, it's continuous. And since negative 120 is less than negative 100 is less than 40, then V of A must equal negative 100 at some point by the intermediate value theorem. And now, number 15. Number 15. So number 15, they've given you a function, f, and they've given you a graph of that function. So this is the graph of the function we're talking about. They tell you that it consists of a line segment, which is this part, of course, and a curve that is tangent to the x-axis at 3. The function is twice differentiable on the interval from 0 to 6, so that's just the curve part. And f double prime of x is greater than 0, and we're going to talk about what that is in class tomorrow. But it's really irrelevant for the question that you're answering. The question says, is there a value from negative 4 to 6 for which the mean value theorem applied to this interval from a to 6 guarantees a value c such that f prime of c equals 1/3? Now, I think I may have in my answer key skipped over a part, so let me re-explain this. In order for a place to be guaranteed that f prime is equal to 1/3, two things have to occur. The graph has to be differentiable along the path, and the graph has to have an AROC of 1/3. All right, so we're guaranteed that this endpoint 6 is included, so I'm going to go ahead and put that there, 6, 1. So we want, first of all, to focus only on the places where the graph is differential. So that means everything that doesn't have a sudden change of slope or discontinuity. So basically that rules out everything past 0, because once we get past 0, there's no, once we get past 0, it's not differentiable over the interval, so nothing is guaranteed. So now in this interval where we could have that happen, we need to find the place where the AROC equals 1/3. And we're told that 6 has to be one of the endpoints. So the 6, 1, we're looking for another point on the graph that would make a slope with the 6, 1 of 1/3 when you take the AROC. And that point is right here at 3, 0. So basically then, the question is asking what's the x value of that point, and the x value of that point is 3. And the justification for the answer would be the AROC is 1/3 and the function is differentiable for the interval given. And there you go.